My name is Angelos Petropoulos, and I'm a senior program manager working in Visual Studio Diagnostics. In this video, I'm going to take you through a tour of IntelliTrace in Visual Studio 2015, talk to what's new, and highlight the improvements we have made to the user experience. First, I'm going to give you a quick introduction to IntelliTrace, explain what it is, how it works, and why you would want to use it to fix bugs. Then, I'm going to show you IntelliTrace in action, as you watch me use it to solve a real bug. In a nutshell, IntelliTrace is a recorder for your debugging session. As your application is running, IntelliTrace is monitoring it for interesting events. Some examples of interesting events are the user performing a gesture such as clicking a button or closing a window, accessing files such as configuration files, executing SQL, or throwing exceptions, amongst many others. Every time IntelliTrace detects an interesting event taking place, it captures the call stack along with some local variable information for that particular moment in time. What this allows you to do is execute your testing steps to reproduce a bug, and then go back in time and examine the state of your application as it was when those events took place. Let's see how you can use this capability to fix a real bug. This is a WinForms application that I downloaded from Code Project, but what you're about to see here applies to most managed project types, including WPF and ASP.NET. This is a social club membership manager, and after I log in, I'm able to register new members, so I'll go ahead and do that just for myself. And you can also search existing members, so you can see or update their information. So I entered my personal information, I clicked register, and Entity Framework is making sure everything is in order. The registration has been successful, and now I can move on to search existing members. The reason why we're looking at this application is because I was told the search functionality behaves erratically. So let's check it out. I actually have two different ways I can search. I can either search by occupation, so I'll go and do just that, and marital status, and I'll search for myself. And indeed, I get back the search result I expected. Or I can use the get all functionality, which allows me to retrieve all members. Now, I've been told that users see unexpected records being returned by the get all functionality. Let's see what happens when we use it here. So we got two results back, even though we only have one member registered. The first record is what we expected. The second one has a whole bunch of blank fields, default values, and unknown for some of the fields. Out of curiosity, I'm going to search for occupation and marital status of unknown to see what that returns. We did get a search result back, but it wasn't the one that we expected. Instead of getting the record that had the blank fields, we got the record that was successfully registered at the beginning of the application as myself. So at this moment in time, I have quite a few theories running through my head. Maybe the bug is with the SQL that gets executed by the get all button, and that's returning records that don't really exist in the database. Or perhaps when I registered the person in the first place, more than one record was accidentally inserted to the database, and the reason why I'm seeing unexpected results is because they actually do exist in the database. Or perhaps the mapping between the drop-downs for occupation and marital status and the actual values in the database is causing the UI to misbehave. So let's take a look at the data that IntelliTrace has recorded. Let's go back to Visual Studio. And brand new in Visual Studio 2015, the IntelliTrace experience has been integrated with the Diagnostics Tools window. All of the events that IntelliTrace has collected appear at the bottom of the screen in the table with the columns event, time, duration, and thread. A new visualization that we introduced in 2015 is the ability to see these events on a timeline above the table. Now, right now, we're zoomed into the last 7.5 seconds of the application. There is not much to see here, so I'm going to zoom out so we can see all of the events that the table has below. You'll notice that the application is still running. Therefore, my scroll bar is going to keep moving and show me always the latest data. Because I want to focus on the data that has been collected already, I have two options here. I can either just move the scroll bar myself, and the window will respect that selection, or I can just hit the break all button, which will make my application enter break state, and therefore there will be nothing else to record while the application is broken by the debugger. So I'm going to go ahead and do that. Now, looking at the list of events that IntelliTrace has collected, there is quite a few of them. So the first thing I want to do is reduce this list to the bare essentials, exactly those events I'm interested in. And since the bug that I want to solve involves ADO.NET events and gestures, that's the only two event categories that I'm going to enable. As I was doing the selection of categories, the database, the events table, and the events timeline were both updated at the same time to show the same data. Now, because I did quite a few things with the application, I started it up by logging in, then I registered myself as a member, then I did quite a few searches. I'm not really sure where the bug is, and I'm going to take it step by step from the very beginning of the application's execution. So I'm going to try and orient myself using the timeline here. Now, the timeline has two different tracks. The first track is showing you the break events, which is any event that was the result of the application entering break mode, whether it was hitting a breakpoint, me clicking the break all button, or a handle exception getting thrown. The second track is showing me all of the events that IntelliTrace has collected other than the break events. So if I look at the very first one, this one is going to represent the gesture of me clicking the login button. The very next one represents me clicking the register button. This is followed by a cluster of events that I'm assuming are related to the registration of the member. And the next event over is me clicking the search button. So I'm going to focus on the registration of the member first by selecting time around the interesting cluster of events. As I did that, my table of events has been filtered just to those that are within the time selection. And if I go to the timeline, I have the ability to right-click and zoom to selection so I can better see the distribution of these events over time. Now that I have oriented myself using the timeline, I'm going to focus on the table of events that I have selected. I start off with the gesture of me clicking the register button, and then I scan the events that follow it, looking for the insert statement that actually completes the member registration. Right at the bottom of my list, which represents the end of my time selection, I see two insert statements into the table club members. Since that's the table that holds all of my member registrations, it's suspicious that I have two insert statements for the same table. So my next question is, why do I have two, and what's different between them? To answer that question, I'm going to select the first insert statement on the list, and here I can either double-click on it or click the Activate Historical Debugging hyperlink at the bottom. Once I do that, Visual Studio enters what we call historical debugging. There is an info bar at the very top letting you know that the state of what you're looking at right now is set in the past, and you should look for other debugger windows that are participating in the historical debugging experience. And in fact, if I look below my code editor, where the call stack window is, I can see that within brackets it says historical debugging, which means that I'm actually seeing a historical stack trace from when this event was generated, rather than looking at the current state of my application. In the same fashion, my text editor has highlighted the line of code that was responsible for generating the insert statement event. Looking at the code, I see that I am within the create method. And looking at the historical call stack, I see that the create method is called by register member. And register member itself is called by register_click. If I double click on the last frame, I'm taken to the event handler for the register button. And this is pretty much what I expected. So nothing seems abnormal about this first insert statement. In order to find out what's different between this one and the next one, I'm going to go back to my list of events, select the second insert statement, and either double-click on this one or click Activate Historical Debugging. The text editor has taken me to exactly the same line of code as before. But if I look at my historical call stack this time, I see that the create method is called by register member just like before. However, register member is getting called by button register_mouse click. If I double click on this frame, I'm taken to a different event handler for the same button. So from this I can deduce that I have accidentally hooked up two event handlers to the same button. And when I click to register a member, the data that I have entered in the form gets successfully saved to the database, the form gets reset, and the second event handler kicks in, which then inserts all those blank fields and default data fields into the database as a second incorrect record. You just saw IntelliTrace in action. To fully appreciate what IntelliTrace has to offer you, think of your typical debugging workflow. When you see a bug, your first thought is finding an appropriate place to put a breakpoint. You then execute the steps that are necessary to reproduce the bug and hope that your breakpoint gets hit and that you can inspect the state of the application in the vicinity of the breakpoint, and that will hopefully lead you to the root cause of the bug. With IntelliTrace, your first thought when you see a bug is, let's see what IntelliTrace has collected. Hopefully, just looking at the data IntelliTrace has collected for you will lead you to the root cause of the bug without having to reuse breakpoints and without having to repeat your testing steps. Even if the bug is hiding in between what IntelliTrace considers interesting events, you can eliminate certain scenarios and you can have a better idea of where to put your breakpoint to be successful. As you saw during the demo, IntelliTrace is integrated into Visual Studio and it's part of the F5 experience. However, IntelliTrace also has a standalone component called the IntelliTrace Standalone Collector. You can use it to capture the execution of an application that is happening on a machine where you cannot have Visual Studio installed on it, such as a production server. You can save the execution of the application to a file, then copy the file across to your development machine, open it using Visual Studio, and then you get a similar experience to what you saw in the demo during F5. That's about all the time we had today. For more information about IntelliTrace and everything related to Visual Studio Diagnostics, please visit our blog, which as you can see on the screen behind me. Thank you for watching.